While an ellipse is the fixed sum of distances between two fixed points, an ellipse is the fixed difference between 2 points. So we'll have that the difference of this length and this length is the same as the difference from this point over to one of the foci minus this one. So I end up with two separate values, or two separate curves, because with distance, I'm going to end up finding, well, two separate curves. So the key point for hyperbolas is that these curves are going to follow slant asymptotes. So here's one, and here's the other. Both of those should have gone through my center of 0, 0. So my equation is going to be based on the slopes of these slant asymptotes. So I either have hyperbolas that face this way, and these hyperbolas are going to point out. And notice that in this case, this shape, we have x-intercepts. So if y is 0, then I can get a solution. But if I tried to find where x is 0, so if x were 0, then I would have negative y squared over b squared is equal to a positive 1. That would never be true, because take a number and square it, you get a positive. Take a number, square it, you get a positive. So negative of this quantity could never equal positive 1. So if my parabola opens sideways, then I'm going to have this form of the equation. My slant asymptotes are going to have the slope b over a. If my hyperbola opens up, so that would be this case, so now I would have curves facing this way, and this was not drawn very well. Let me lift this up some. So now in this case, I would have something like this. My center again is at 0, 0. I stick with the a over b, but in this case, my equations are going to have, my slant asymptotes will have the equations plus or minus a over b. So the way I can remember this is that the numerator is always underneath the a value. So the numerator of the slope always corresponds to being under the y. Okay, so this equation then would have the equation y equals a over b x. This positive 1, y equals b over a x. And we're going to stick to going through the origin for our hyperbolas for the center. As you might expect, I could shift the center this way, but then it's also going to shift my slant asymptote equations. And so for the sake of this class, we're going to stick with just the 0, 0 and these as our slant asymptotes.